Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic is guided component testing level 2. So if you joined us last time, we went through the high level overview intro to guided component testing. Why do we want to use guided component testing, and what does it do for us? This time we'll get into the more advanced functionality of guided component test, adding additional channels, changing screen views, setup functions. All right, so we'll talk more about that after we go through a case study, which will bring us there. So there's a case study on a 2011 Subaru Forester, and it has a flashing check engine light. So that's the customer's concern. Under hard acceleration, the engine light flashes, and only under a hard acceleration. So for example, merging onto a highway, trying to get up to speed, or going up a steep incline on a hill. Those would be the times. 100% throttle, 100% load on the engine, really good load on that engine. That's where that engine light would flash, right? The other thing is cruising normally. So let's say we're merging on at a highway, we have a flashing light, then we get into the lane and we're just cruising part throttle, part load there, and no engine light present. So the only indication that the customer has that there's anything wrong with the car is that the engine light flashes under a load. Also, no other drivability concerns. Even under that load situation, they said they really didn't notice much going on with the vehicle other than the engine lights flashing, which would be their main concern. So where do we start? Well, of course, best practice is always to start with that full vehicle code scan. We want to scan all the modules on the car to see if there's any codes in there that aren't necessarily turning on a light. Could bring us in a good direction. So we see at the top of the screen there, it says code scan. So we click on that, comes down, and it looks like in history, in the history codes, we have a cylinder 3 misfire, right? And that's probably why the engine light wasn't on, because it's not an active code. It's not currently a problem. It was a problem before. That's what history. Subaru's set up that way. They have current codes and history codes. Few other cars are set up that way as well. So we have that separate history code entry there. Now, if we look on the right-hand side of the screen, the right-hand side of that code, it says diagnose. So this is on a Zeus, and Zeus has intelligent diagnostics as well as Apollo and Triton. Those four tools, really, if we count the 2 Apollos. But out of those tools, they have what's called intelligent diagnostics. Now, if you're familiar with intelligent diagnostics, or if you're not, here's what we're going to see what more information we can get by clicking on diagnose. By clicking diagnose, it brings us into that intelligent diagnostic screen to see what information we have for this problem. Now, what it does, if you're not familiar with it, is it takes all the information in the tool and filters it down just by the vehicle and just by the code. So it's code-specific, vehicle-specific information based on billions of real-world repairs. Taking all that information and laying it out in a workflow. There's a patented workflow that we have. And all you have to do is just follow this page, top to bottom, left to right, just read it like a book, touch on all the sections, and it'll walk you through a complete diagnostic procedure. So first things first, on the top left corner, we see it says technical bulletins, and there's a number 4. So that means based on the P0303 for a 2011 Subaru Forester,
there are 4 TSBs that apply to this problem. So if we open that up, let's take a look. So first one there, it says difficulty starting, rough idle, cam position or misfire DTCs, bunch of P03 codes involved there. So let's click on that. Go through, tells us, date of issue, all that, what vehicles it applies to. Looks like 2011 to 14 Forester. So it was the first year of the Forester for the first 4 years of the Forester there. It says this bulletin provides inspection and repair procedures for intake and exhaust camshaft position related and or engine misfire DTCs for the FA and FB engine equipped models listed above. Here's the interesting line though. The camshaft position sensor clearance may be out of specification causing these conditions. Right? So this bulletin walks us through how we would address that. So why would camshaft position sensor clearance be an issue on a car? Well, if we take a look at the, here's a exploded view, right? So we have the cam sensor there, that's where it goes into the timing cover. So it's big metal timing cover across the front of the car, horizontally opposed engine. So we have 2 cam sensors, 2 camshafts, 2 intake camshafts. And then we have the 2 cam sensors on the top corners of either side. And here's a cross view of that cross-section view. So there's where the sensor would mount. There's the sensor itself. There's the connector. There's the electromagnet part of the sensor. We'll talk more about that in a second. And then there is a metal wheel or metal disc attached to the front end of the camshaft. And that's what tells the cam sensor what's going on with the engine, or at least what positionally what's going on in the engine. So how does this work? So on this vehicle, it is what we call a digital Hall effect sensor. Hall effect sensors used all over the vehicle. Many different types of sensors, many vehicles use this type of system. So what a Hall effect sensor does in a nutshell is it generates a magnetic field. When that magnetic field is disrupted, however it is disrupted, it will generate some sort of a signal. There's multiple different ways it can be done. On a 2-wire sensor, it'll usually just be an AC type signal, go up and down on either side of 0 volts. On this one, it's a 3-wire sensor, so it puts out a digital pulse. Depending on how it's wired, depending on how the manufacturer decides they want it to be used, it could be, for example, a steady 5 volts and then it pulls down to ground when it creates the pulse. Or maybe like in this case, it is a steady 0 volts and then generates a 5-volt pulse when it affects that magnetic field. Right, so we'll see a pulse of some sort when it's this digital sensor. So this has 3 wires, power, ground, and a signal. So let me put this into motion and just kind of show you what we're talking about. So we see the blue lines represent the magnetic field. And then as this disc spins, we have those dropout notches. You'll also notice the bottom of that magnetic field, it's wide open, right? It's not touching anything on the corners. It's not touching the corner. It's not touching the bottom. It's well apart. So let's just say that this is a good gap. This is the amount of air gap we want on the sensor. Now, what would happen if that sensor was too close, if that air gap was too small? So let's bring it in a little bit closer. Now you'll see the magnetic field doesn't change, right? That's a constant. But now it's closer. So we see the outer edge hits the corner there, goes down a little lower there, goes down a little lower there. So this metal disc, which hasn't changed, magnetic field hasn't changed. It's just our air gap is closer. So now this metal disc will affect that magnetic field in an unexpected way. Not necessarily, don't necessarily know what that is going to do to the signal, but it does affect it in a unexpected way that the engineers didn't account for when they went and programmed the logic for the computer. So let's say in this example, so we see way more material go by, it's affecting it a little bit differently. So now we have a longer pulse. All right, so let's say now in this case, we have a much wider 5-volt pulse than the small one we had before. All right, and that's just kind of how it would affect us in this case. So let's go take a look at what Subaru has to say about this. So we go into the bulletin. First thing it tells us is you need to use a scope to figure this out. If you don't have a scope, it's going to be very difficult to figure out if you even have a problem. So screenshots on a Subaru lab scope, any lab scope, 3 or more channels will be able to set it up exactly the same way. We have crank sensor on channel 1, right side cam sensor on channel 2, left side cam sensor on channel 3. And if we take a look, we have 2 gap. You see I have two kind of open holes there. Then I have a gap and a pulse, single gap, single pulse, single gap, double gap, single pulse, and then single gap, and then single pulse, single pulse. So depending on how the combination between the double pulse, the gaps, and the pulses on the cam sensors tells the computer what cylinder is where and what cylinder needs to fire. And if you drew a straight line vertically through all of these, I think you'd agree that all of those gaps line up. So in this case, Subaru has given us a known good pattern, which is kind of nice because not every manufacturer puts out a known good cam crank correlation, right? So in this case, we have a known good cam crank correlation to go off of. That's kind of nice. We go a little further into the bulletin, it shows us an example of a bad pattern. And we see it's only on that right side cam sensor, second one down. And we see I have my normal blips, but then I also have larger ones, slightly larger ones, very large ones, right? So a lot of different size squares going on here. And this is because that magnetic field is being disrupted differently. So this, where this large square is right here, right by number 2, that large square isn't supposed to be there. None of that is supposed to be there. This would be where, if we looked on the known good pattern over here, it would be the empty hole right there. That's what should be, because we have 3 blips, right? 1, 2, 3 normal blips. So 1, 2, 3 normal blips, and then that would be a bad. It's not supposed to be anything there. So in this case, it is. There's a very large square there. And because of how those line up, now the computer is confused. It doesn't know what cylinders where in their firing order. So maybe it doesn't fire a cylinder. Maybe it fires the wrong cylinder multiple times. So it gives us an issue like this. So if it's severe like this, this probably would have been noticed pretty early on in the car's life. Probably would have given you a starting problem, rough idle problem, that sort of thing. But if it's a case of this customer's car that we have, maybe it's just very slightly off. Maybe it's just right at the outer edge of where it's not okay. And then under that load, things move, things flex, things move just that little bit where it brings it into the bad zone, right? So I'm suspecting in this case, that's what happened. So that's all well and good. And then we go through this. Basically what it tells you is, how do we fix it? So you go through and you break out a depth gauge, you measure the depth of from the wheel to the flat spot where the cam sensor goes. If the gap is off, you insert the proper size shim. There's 8 different shims. Once you've done that, you double check with the scope. If everything looks good, you send it on its way. All for one of a $6 little shim. Now, I don't know about you, but if I ever get a car in with a P0303 code and cylinder 3 misfires, probably not the first thing I'm thinking of, unless I'd seen this bulletin before, unless I'd experienced it before, right? Maybe we check the coils, maybe we check the plugs, maybe we check the injectors, right? All the usual suspects first. But in this case, we had the bulletin to go on. It was right there, first thing, and use the guided component test or the scope to figure it out. So how would we figure this out using the Snap-on equipment? Here we are a little further down the Intelligent Diagnostics page. And third one down there says guided component test meter. So that's how we would access the specific guided component test for this problem. So if we go in there, first 2 things on the screen are the crank sensor and the cam sensor. So that's our filtered list on the top. So these are the things based on data that we think will apply to this code on this car. So crank sensor and cam sensor first. Let's go to cam sensor, because that's what, if we had that strange pattern, it would show up in the cam sensor. So we go in there. If we wanted to, we could go to component information, learn a little bit more about it. We just kind of went through that whole thing. So we'll go straight to the signature test, because that's what we were looking at when we were looking through that information on the TSB, was the signature test. So we'll click on that, go through, and what it does is it automatically sets the voltage range where it needs to be, automatically sets the time base where it needs to be, and we connect our leads. So our yellow goes to cam signal, black goes to a known good ground. So that means we'd plug into number 2 there in the middle, and then black to a known good ground. And we see 2 of the patterns. There's the hole in the middle where we wouldn't have a problem. So we don't have a problem in this case. So we don't see this extra square there, right? So there's the cam sensor. We back up, we can go to the crank sensor, same thing. Load the signature test. In this case, this is an analog Hall effect sensor, right? So it gives us a positive and negative voltage, in this case, roughly around battery voltage, right? About 12, 13 volts on either side of that. There's my double gap that we saw. There's the single gap that we saw, double gap, etc. Now, how would we set this up to make it look like that Subaru set up inside the TSB. So then we can just compare apples to apples, right? Well, we can do that inside the guided component test module. Most people think that it's just designed to test one thing at a time, and really ideally that's what it's for, but we could add additional channels. A lot of folks don't know that. You can add additional channels, you can change the settings, you can change anything in here that you'd also be able to change in the scope or graphing meter. So how would we do that? We'll go up and click meter just to make things a little easier to see. We go on the bottom right, that brings up my settings. On the settings, we look on the left-hand side, I have these eyeballs. If I click additional eyeballs for channel 2, channel 3, etc., it will turn on additional channels. So now I have channel 1's my crank sensor, channel 2 and channel 3 are my cam sensors. They're all on the screen at the same time. I would have had to change some things, but we're going to walk through that when we go live on the tool in a minute. But in this case, I have all 3 on the screen. Right, that works. But what if you have a 2-channel tool, right? What if you have a Modus or a Triton or a Vantage? In that case, you could still do this. You would just be able to add 1 channel at a time. So maybe keep that crank sensor on there on channel 1, add channel 2 for one side cam sensor. Then if that looks okay, change it to the other side cam sensor and kind of see where they sit. All right. So it still can be done. You just look at 2 at a time. For additional use of this, now, if we had a 4-channel tool, we can add a 4th channel with something that fires 1 time through our firing order. That way we can see all the cylinders on the screen, and if we know the firing order of the vehicle, we know what cylinders where. So in this case, we hooked it up to the number 1 fuel injector. So you can see that's the red channel there, number 1 fuel injector. So every time that fires, we know that's number 1, right? So there's number 1 there. And then 3, and then 2, then 4. 1, 3, 2, 4 is the firing order. So 1, 3, 2, 4, etc. So now I know what cylinder is what on here, and I know where the problem might be if I did have a problem. Otherwise, this really does look a lot like the known good pattern, right? Now, there is a lot going on here, and the Subaru scope had them separated right on top of each other. Well, we can do that as well in here. So if we go in, and there's some setup functions that I'll walk you through. We can set it up so channel 1, 2, 3, 4 are stacked on top of each other, and we have pretty much the same look as we had on that TSB. We could even take this 1 step further and make it so we can see both on the screen at the same time. So if we look at that, we can move our scope on the right-hand side, we can have our TSB on the left-hand side, and we can compare across the board, apples to apples. How's my crank look versus this known good? How's my cam look versus the known good? And we can do that. And I'm going to show you exactly how we'll do that right now. Well, let's walk through. So if you're just joining us, if you're on Zoom and you have any questions throughout this presentation, just make sure you put them in the Q&A box. So look top bottom of the screen, click on Q&A, and that'll open a new window. You can submit your question there. Or if you're joining us on YouTube, with live on YouTube, then we can use the live chat function. All right. So if you have any questions while we're doing this, live chat function goes away after it's a down view on demand video later. But for now, we could do chat if you have questions. So feel free to enter those in, and I will go on to my Zeus. Okay, so here we are on the landing page, the Intelligent Diagnostics page for our P0303 on this 2011 Subaru Forester. We see the 4 TSBs, so click in there. We'll do this in real time. And we see our number 1 TSB we were looking at before, so click on that. Downloads the information. There's our applicability, so 2011 to 14 Forester. Go through the introduction. It tells us about the camshaft gap. And then we have looks like there was a countermeasure in production. So they changed the way they were building these cars, starting with that VIN. So if it's before that VIN, it could have the problem. If it's after the VIN, it shouldn't have this problem. And then we come down here. Here's my different shims. So I said there's 8 part numbers, right? So it goes from 1/10 of a millimeter up to 8/10 of a millimeter. Here's our depth gauge. So there's a digital depth gauge and a flat level spot adjuster or adapter. If we don't have that, we could also use a flat washer. Come down a little bit further, and here is our known good pattern there. So we see we have a 2 gap and a 1 gap, they call it, right? So the double gaps and then the single gaps. based on where these line up and where these fall, gives us what cylinder is what. So the firing order is 1, 3, 2, 4. And then we see, so crank signal would be a 1 gap. And then if cams, right cam and left cam are both giving a signal, then that would be number 1, and so on and so forth. There's the different combinations. If we have the problem, as we have down here, and we showed a little bit earlier, so that is showing a 2 gap, a blip, and a blip, where it's supposed to be a gap. So that means it'll fire cylinder 4 every time this combination happens. So really, in this case, it's firing 4, 2, 4, 1, 4, 2, 4, 1, never fires cylinder 3. So that would be an extreme case of this problem. If you go down here, this is what we say could be an erratic signal, but it falls outside of the window, right? So this is still not necessarily correct, but it's right on the edge of where it would cause a problem. All right, so we have the gap, and still everything would fire just as normal. All right, so there's where we put our shim in between the cam sensor and the timing cover. Measure that gap, make sure it's okay. There's our plate with the notches. There's measuring the depth with the depth gauge. All right, there's measuring the depth gauge with the flat washer instead. And then we just do a little bit of math and figure out what shim it is. All right, so that's the exhaust cam on the BRZs for that as well. So there's our known good right there, right? So we went through that material, and we want to end up on this screen, right? We want to have the TSB on the left-hand side. We want the guided component test on the right-hand side. Now, I could go into the guided component test through Intelligent Diagnostics, but I won't be able to do the screen because the TSB is also an Intelligent Diagnostics. So we need to open a separate component test window. So to do that, we go to the home screen, and we just go straight into the guided component test module from here, because Intelligent Diagnostics is in Scanner. We go to guided component test. Going to confirm our vehicle, and then it's going to load our list of systems, 7 different systems to choose from on this car. Cam and crank live inside the engine. Once we load engine, we see our different list of components. I will go to crank position sensor because that's where I want channel 1 to be. All right, so we could go to component information. Let's just go straight to that signature test again. Yellow to crank positive, black to crank negative. We also figured out that it was those analog 2-wire signal, right? So we'll hit view meter. And this is set up from last time. So you're going to kind of get a little preview. I'm going to get rid of that. We'll walk through that again in a minute, because I did a class earlier tonight. So, all right. So here's my crank sensor. We see the 2 gap. We see the single gap. And it is just sitting there on the screen, about 7-8 volts on both sides. Okay, so we have that. Now we wanted to add our cam sensors, right? So let's go up to where it says meter. Open that. And down the bottom right, we have our different views, different screen views. So 1 time gives us measurements, twice gives us our settings. Now I have everything hooked up to a simulator, so we should be okay. If we click on channel 2, channel 2 is on there too, and that's my cam sensor. Now, if we look, there are the teeniest, tiniest little bumps there going by on channel 2. Now, why is that? The guided component test presets the voltage range and the time base for the signal we're originally testing, so the crank sensor. If we add additional channels, you may have to change the settings depending on what signal you're reading. So in this case, my voltage scale for channel 2 is set at 400 volts. So that means it's 0 volts down here, 400 volts at the top. The cam sensor is a 5 volt signal. So out of 400 volts, how big is 5 volts? Not very big, right? So we need to change that. Now I could change it to 5 volts. If I do that, it'll take up the entire height of the screen. I want to have a little bit of extra room on the top. So I'm going to set it to 10 volts. That gives me where it only takes up half the screen. If I wanted to set it to 5 volts, you see how that's very top to bottom, kind of hard to see what's going on. So we'll keep it at that 10 volts. Now we're looking at 0 volts on the bottom, 10 volts at the top. It's a 5 volt square wave, so that'll be right about in the middle. So there's channel 2. Channel 3, the other side cam sensor. Now we see they're both on the screen, but the blue channel looks smaller, right? The blue channel looks like it's half the size of the green channel. And that's because the voltage scale is 20 volts instead of 10. So we'll change that down to 10 as well. So there we go, top, bottom. I can bring this down a little bit, put them on top of each other. So now we can see cam, crank, both sides cam and crank. Once again, this is it's a lot of stuff going on here, and it's moving across the screen considerably. It's kind of hard to see what's going on. So I want to add that fourth channel as a trigger channel. So in this case, it's going to be a square wave. So the signal generator does a square wave. So in this case, on a car, an equivalent signal would be, say, the number one coil. The control signal for the coil is usually a 5-volt square wave. So we'll add that in on channel 4, and that's up here on the top. All right, so there's my 5-volt square wave there. There's my cam and my crank. Now, it still didn't do anything for me to freeze it in place and lock this in place, make it easier to see, because we have to change where our trigger is. If we look on this last column on the right-hand side under slope, there's where my trigger point will be. Now, this squiggly line, this shows us what channel the trigger is on. So if we look over here on the left-hand side, we see this plus sign. Anytime the voltage on that channel crosses that plus sign, it will start drawing the picture from there. In this case, it is a constant up and down on both sides of that plus sign, so it's just going to constantly move. We want to have it on that one time through pulse, that coil. So I'll go down to channel 4, click on that, and that turns on my trigger point. And now everything's there. Everything's lined up. 1, 3, 2, 4. 1, and repeats. So now I can see everything on the screen, see how they line up within the windows. Once again, simulator, we're pretty close. Real car would be, a little more centered, but close enough. So here we have it on the screen. Now, still a lot going on, right? I got my greens, my yellows, my reds. Everything's kind of blending together. So let's change that setup window. You saw a little preview of that earlier. Let's set up the layout of the window. So if we go up to the top where it says setup, click on that, and we'll click view, and we'll click layout. Now, one window is where it defaults to. So everything's all in one window at once. 2 windows will give us channel 1 on the top, channel 2 on the bottom. 2 windows side by side will give us channel 1 on the left, channel 2 on the right. 3 windows gives us the first 3 channels stacked, and then 4 windows gives us the 4 channels stacked. All right, so we'll leave it there. I'll hit exit. Now, one other thing, I want a little bit more screen real estate here for these patterns. So let's get rid of all these settings. We already got it set up. We're good to go there. So down the bottom right, we touch that square again, gives us our 4 channels by themselves. Almost there. Now we want to do that screen and screen side by side. So all I have to do from here is hit meter one more time. Gives me that window. Go to the home screen, back to the scanner where our TSB is still sitting. Windows-based tools, we can have multiple things open, right? So we have that on the left. From here, I go down to the bottom where my taskbar button is. Pulls up my Windows taskbar. I see Scope Viewer. Click on that. Opens my scope. Now they're on the same screen. Now I want to adjust it, though. So I can take this blue bar, this top of the window here, grab it anywhere with my finger, my stylus, my mouse. Drag it to the right-hand side, and now we see how half the screen has like a gray box around it, right? That means that window is going to snap over there when I release. So as soon as I release my mouse, it snaps over to the right. Now this tool has Windows 10 on it, so in Windows 10, it has you select what window you want on the other side, and it'll move it there automatically. If you have a Windows 7 tool, you can just grab the other window will be kind of back here over on the left. You just grab the top and move it to the left, just like we did on that other side. But since this is Windows 10, I click my window. There it is. Shuffles it a little bit down, but here's my pattern from my TSB. Here's my pattern coming from the simulator. Looks like they are pretty close. All right, I can see all my signals on the screen at the same time, and they pretty well match with each other. So those are some more advanced features we'd be talking about with that guided component test, right? Now you could take this, say you wanted to have your scope on one side and you wanted to have a functional test on the left-hand side, turning something on and off, watching the result. You could do that easily using the same method. Maybe I want to look at my voltage is coming off a sensor, and then I want to look at my voltage readings off the process data on the left side, right? So I can compare in and out, or at least the computer's interpretation, like we talked about last time, right? So we could do all this by having these double windows, right? So there is your more advanced guided component testing.
And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully, we'll see you next week. Hopefully, you can watch and see you on any of our other videos. Have a good week. Have a good night and take care.